if we keep staying in cave-dwelling mode of considering that Michael Faraday's homopolar, unipolar disk is strictly a DC situation and not at all amenable to an AC application, then it's no small wonder that we can't take William Lyne's portion of his story seriously concerning the chassis, the iron chassis, being magnetically coupled to a very large mass of iron, as being significant, because then we can't take seriously one of Tesla's patents. Now let me see if I can find it here. Here we go. I found it. I downloaded it. It's patent number 433702. 5th of August, August 5, 1890. It's called electrical, excuse me, electrical transformer or induction device. And that's the one where he talks about magnetically separating the primary coil of a transformer from the secondary coil by a membrane of magnetizable barrier or iron. There's even substances more powerful than iron nowadays. And regulating the power factor of that transformer by virtue of the various design characteristics, such as, the coils themselves, the thickness of the membrane, the iron membrane, separating them, magnetically isolating them to a limited degree, because he says that within a certain amount of time, I guess within each half phase of, the AC cycle, that piece of membrane is going to become saturated and then allow itself to transmit magnetic influence beyond it. So it's just a retardation. In fact, it's increased retardation of the secondary current is what he's saying. So by doing that, I would imagine he's doing something to either the current or the voltage to cause it to lag behind the other. And that monkeys with the power factor, which monkeys with our ability to do some pretty amazing stuff along the lines of what William Lyne has described when he tested in the late 70s 2 old meters over 100 years old in one of his apartment units in the apartment building that he was managing, or he owned as well. And he got the meters, those 2 meters, he got those 2 meters to run backwards, and he got them to snore when balance of load occurred. And the main meter on the main building reduced his overall electric bill. So it wasn't something rinky-dink. He was actually creating power by virtue of the fact that that's the only way you can do something like that, is to actually legitimately create power. Well, Adam Trumbley has already described this, and Brian Strom gives some hints as well, and Tesla gives some hints, and this is one of them. And Patrick Kelly on his website, if I can remember the name of his website, let's see, Free Energy Info with hyphens in between, free-energy-info.com/chapter4.html, but chapter is hyphenated, capital C, and then lowercase HAPT, and then the number 4.html. That was the page I got very focused on gravity devices, because that told me about slippage, which is important, and it told me about some people actually monkeying with the power factor between a motor coupled with a generator. They had a drive shaft going between them, maybe some pulleys, whatever, but then the generator fed back to the motor. And so by monkeying with that power factor, we can actually change things, and that's what the Meterman's Handbook from 1912 alluded to, the copy I got from eBay, that snoring, or balance of load, as William Lyne describes it, according to that book, is when you have a difference between the voltage and the current of 60 degrees. Now, which goes ahead of the other, I can't remember. Now, Tesla in this patent says he was looking for obtaining 90 degrees difference between the voltage and the current. And I don't know what effect that has. I don't know anything. I'm just saying that it's possible. What William Lyon is saying is true. And it's verification from Tesla himself in one of his patents. And I think that's pretty significant. So, now I remember what I was trying to say. So, I think Adam Trumbley did something that few people have done. A few have, but not too many. And that is turn Michael Faraday's homopolar or unipolar disk into an AC output situation. It may be DC oriented at its core, but from the looks of things, just reading a few of Tesla's patents, I just assumed that everything is DC, but we know that Tesla likes to manipulate electrical dynamics, and AC is a good, efficient way to do that. You can have a harder time with DC. Although DC has its advantages, and that, or else somebody like Tesla or Adam Trumbley or Brian Strum would not waste their time studying a homopolar or unipolar situation. But ultimately, if you really want to see some power gain, you have to convert it into an AC output somehow. And then you can really see some benefit, apparently. Because then the chassis, the magnetic grounding to a large body of iron from an iron chassis, serving as a membrane to retard the difference between the current and the voltage, make the current retard. If it retards, it's able to build up. And that must be why or how Adam Trumbley said he got saturation of current on his disk, because he backed it up. Because of how he took the current off the disk was not in a mere simplistic DC fashion. Now, Brian Strum said it's a DC unit, but at its traditional, conventional sense, but maybe there's a way to bring it up to date, so to speak, and turn it into something AC, because Michael Faraday, AC didn't exist in his day. So yeah, it would maybe take somebody like Tesla to think, hey, I can get more out of this if I turn it into an AC situation after it does its magic in its DC mode, this homopolar or unipolar disk of Michael Faraday. And as far as I can tell, Tesla, nobody knew about unipolar disks back in the day of Tesla. They only know homopolar. They only knew. The unipolar was first identified, according to Adam Trumbley, in the 1950s. I guess a physics journal of some sort. And it's a very significant finding, but apparently Tesla didn't know about it. I don't know. It's hard to think that Tesla wouldn't know something like that, something so simple. Whatever, we can only speculate. Anywho, I guess I figured out I had the answer right in front of my face. You can turn a homopolar disk into an AC system very easily by putting grooves into the disk. Now, Brian Strum connected those grooves, each one of them on his modified unipolar disk. He connected those, they weren't grooves, but he did something else, but it was similar, it was radial. He connected them in series. And according to Tesla, if you have grooves, you literally have current going up the ridge of each radial groove. Let me get a picture. Okay, so Tesla said to put grooves into the pickup disc, the copper disc that he has rotating between the poles of an electromagnet, the core poles. It's an electromagnet. So actually the hole in the middle is larger because he has the coils for that cord electromagnet right in here in the middle, and then he's got the poles of the core on the outer edge, so it really should be like a frisbee flat disc. Anyway, he's got ridges, serrations, that he cuts with it like a table saw, let's say, radially coming out, and this is just a few that I drew, but there's a lot more. And he says it's arbitrary how many you put in, but this is how he turns, how he creates an alternating generator that can put out 150,000 cycles per second or whatever you want. So what he says is that along the ridge, in between the valleys, the ridges, the current is flowing outwards. And in the valleys, it's flowing inwards. No, excuse me. No, he does two ridges. He also puts ridges on the pole pieces, on the pole faces of the electromagnet facing this. And he's got two ridges on this disk for every ridge on the pole piece, the core of the electromagnet. So one ridge is going to be in the valley, one ridge of this conductive copper disk will be in the valley of the, between the two ridges on the pole piece, while its surrounding two ridges will be along the ridges of the pole piece. So the one in the valley, the current goes in because it's collapsing, because there's no magnetic field coming out of the pole piece within the valley, as we've seen on ferrofluid videos on YouTube. All the magnetic field comes out the edge of the ridge, and the gouged out valley, no ferrofluid attaches to that spot. But along the ridges on the copper disc that align with the ridges of the pole piece, of the core of the electromagnet, there the current flows outwards. So it'll be out and in and out and in, just like what Byron Strom did on his modified unipolar disc. But this is an AC generator doing the same thing. So the way Tesla had it set up, and I still don't understand his diagrams, but I can at least understand the concept, he took the power off the outer edge, just like you would do on a homopolar or unipolar disc. And because you can space your commutation pickup, because every other ridge on the copper disc is either energy flowing in or energy flowing out, you've got yourself an alternator situation, a commutative alternator situation already built into your copper disc. So it is possible to take a Michael Faraday either unipolar or homopolar situation generator and convert that DC into an AC system just by putting ridges in. I think what Byron Strom did, he didn't put ridges though, but they were radial. He put in, he made like a, what do you call those things? When you make a circuit board, you make the pathways any way you want, a custom-made circuit board. He literally, I think he did that when he made his disc, so that he could have pathways by his design. But he had linked them up to go in and out, one continuous series, so it was still DC. It wasn't AC. I don't know why he did that. Maybe for increased power gain, possibly. Now in Tesla's patent, he had a humongous core for his electromagnet facing this disk. The disk was stationary and the magnet rotated, which is kind of weird because it would take a lot of energy to get it up. Oh, because it would serve as its own flywheel. Oh, that makes so much sense. But the core, the two cores that faced on either side of the single copper disc, well, the setup was only one copper disc, so it's not counter-rotating, but it's because it's homopolar. Okay, so at any rate, he figured out how to make it work. So this is the confirmation to the groove idea, putting grooves in the conductive, non-ferrous conductive disc, is that you can set up brushes on the outer edge to turn this into an alternating system. And brushes, contacts on the inside too for that matter, but they can be arranged in such a way as to create an AC system very, very readily. Now you still got friction from the brushes, obviously, but it can be an AC output. And once you got an AC output, now you can monkey with the power factor by having your pickup coil outside the iron chassis of this thing and magnetically couple the iron chassis to a much larger body, massive body of iron held separate from this device. It doesn't have to be far away. It's just whatever's convenient in terms of distance. Now it might be better that it surrounds the device. It's just a much larger chassis, and that of course qualifies as the hull and in the interior geometry of an electro U-boat, or a U-boat during the Nazi era, converted over for electric drive use during World War II. So let's see, where's the patent again? So this is the patent for the high alternating electric current, 150,000 cycles per second or more. Then we get the other patent, which is the one having to do with the magnetic membrane to separate the primary from the secondary, showing that you can create a power factor in a transformer, in an AC transformer, and monkey with the power factor to get the kind of output that William Line talked about in his watt-hour meter experiments in his apartment building. Now this is a file that I got off of Peter Lindemann's website, having to do with describing the performance of the Sunburst version of N-machine. Now, Adam Trombley doesn't like the term N-machine. He thinks that's not correct. But be that as it may, it's a very simple setup. And I made a, let's see, where did I put it? I made a little GIF or image because I had to take it out of the PDF file and turn it around. It was sideways. There we go. So now I got to make it bigger. Whoops. Yeah, there we go. So we basically have sandwiched two ceramic discs with the north and south pole facing each other, but sandwiched between them is a copper disc. And the thickness of the ceramic disc is twice that of the copper disc. And it's just standard. You take one lead off the axle and one brush off the edge, or the edge of, off the edge of the copper disc, and you put a load there, a resistor. So it's really not that complicated what they used, but the power gain was unbelievable. Just this simple little device. Now this is unipolar because the magnets are rotating with the copper. They're bonded together, probably glued. So if we go back to the, they had a over unity factor, a COP of, there it is. No? Right. Okay, where are we here? 28.2. 28.2. So they had 7,500 watts out for 268 watts in. Can you beat that? A coefficient of performance of 28.2. And they believe that if they used mercury brushes to take off as their contacts, that they could double that to 46.25, because they felt a lot of resistance was in those brushes. Can you imagine that? Close to 30 COP, and this is just a simple little deal. Nothing complicated. This is nothing like what Adam Trombley described, saturation of current in the disk. And this is nothing what William Line described either in Tesla's special generator. But still, that's pretty good for such a simple little device that doesn't amount to anything. I mean, just 3 little discs sandwiched together. I mean, boy. Wow. So that's pretty cool. Well, looking over his patent, it becomes obvious that it's a little complicated. He's showing here a motor, a generator, and 2 transformers. I guess because each one is 180 degrees out of phase from the others, so he accommodates an AC situation by having a separate transformer for each half cycle at any one point in time. That's what I get out of looking at this. I don't know why else he would have two instead of just one. So I have to examine the wiring more thoroughly because I don't quite understand the wiring. But it looks, the way he describes it's very simple. He puts the core, the iron core, that's the center, and he just uses a mass of iron wire that's been insulated. And then he's got the secondary winding around it. Then he's got the magnetic shield, which is more iron wire surrounding the secondary, and then he's got the primary on the outside. So the primary is not shielded to the outside environment, and certainly he doesn't show it to be shielded from this arrangement over here. And if the two are out of phase 180 degrees, I would think that has some bearing on the situation. So he leaves something out of this, and that is, well, why not just magnetically shield these two transformers from each other and from their environment and connect that overall chassis to a big, huge mass of iron to act as your magnetic sink. But what he does say, though, he talks about continuous, the need for the current to be continuous, and I think that's the purpose of the sink, is to ensure stability to what you're trying to do. The other thing he says is that by varying the thickness of the magnetic shield, you can retard the secondary from picking up what's happening from the primary. So it's pretty straightforward and not too complicated. It's just the geometry of the thing. And this is patent, again, this is patent number 433,702, electrical transformer or induction device, August 5th, 1890.